Vanakkam. Welcome to this course on biomedical instrumentation. We were looking at ventilators. So, in this video, we will look at modes of ventilation and taxonomy of ventilator modes and what are the commonly used ventilation modes. This is one of the most critical aspects in ventilator function. This taxonomy essentially refers to an operating system, like you have a software operating system for the ventilator. Recall that ventilators are among the most advanced and well evolved engineering systems, essentially working at the cusp of respiratory physiology, controls engineering, control system engineering and information from clinical practice, clinical medicine. All these things go into integrating and improving our ventilator function. What are the modes of ventilation? Essentially, what this refers to is a specific set of approach or algorithm that you use that are used to manipulate specific variables for delivering a targeted amount of volume and pressure. There are different methods. First is the control variable. This is the what. Second is the particular breath sequence, the when. Third is the target scheme, the how. This is the how mode. These are various different things. Consider a balloon is being filled at a constant pressure, right, or with a target pressure, with a constant blowing. You are trying to fill a balloon. Now, the volume will change as a function of balloon stiffness, or let us say you have a constant volume syringe with which you are pumping air into the balloon. Well, in that case, pressure will change as a function of balloon compliance. So, things to recall. Something similar happens in the case of lungs. Of course, the lung is not a simple balloon, something to keep in mind, but still just giving an example. Okay. So, essentially ventilator breath control variable can be pressure or volume or essentially one of these two. The breath sequence, we discussed this in the previous class, that can be continuous mandatory or intermittent mandatory or continuous spontaneous. Yes. But and the control algorithm or the targeting scheme essentially refers to the control algorithm, that could be a set point control or some form of adaptive control or some servo control or some optimal control. These three combined together, synthesized together, will essentially define the mode of ventilation. This is the mode of ventilation. So, there are several combinations of these that are possible, several combinations from each of these three dimensions that are possible. Okay. These three together will decide the mode of ventilation. Now, this picture essentially refers to the Chatburn taxonomy. This essentially refers to the Chatburn taxonomy. What are the defining features? What are the various types? What are the ways in which you could? These are the breath sequences. These are the control variables. These are the control schemes. Right. So, and there are combinations of these. So, there are overlaps between this Venn diagram. Essentially, has overlaps between several possible approaches and dimensions. One method is for example, PCCMV, in which it is essentially the pressure controlled continuous mandatory ventilation. This is the first in emergency mode, first mode to be deployed in the case of emergency. Okay. This is the first in emergency mode. It is a mandatory mode that does not allow spontaneous ventilation. pressure variables are set because this is pressure control. So, pressure variables are the variables, set variables, while volume and flow change as per the dynamics, system dynamics, respiratory physiological condition at that stage, pathophysiology at that stage, and breaths are completely machine cycled. This is the mode to be deployed in case of emergency, because we do not know what the internal condition of the patient is. The various things that are that can be controlled are PIP, PEEP, tidal volume, MAP-IE ratio and respiratory rate are the various things that can be controlled. Note that the pressure is only controlled during inspiration, because expiration is a passive process. Is volume controlled? The answer is volume is controlled, but indirectly. Remember, because volume is controlled indirectly, even otherwise, because there might be some safety mechanisms, can still cause, despite all that, can still cause villi or volutrauma. Right. Ventilator induced lung injury is a possibility. Villi means ventilator induced lung injury, that is a possibility, or volutrauma, villi or volutrauma is still a possibility. The second is the volume controlled CMV mode, volume controlled continuous mandatory ventilation mode. In this case also is a mandatory mode that does not allow spontaneous breaths. In this case the volume variables are set variables, whereas the not volume and flow, whereas the pressure and flow change as per the situation of the patient. This is the mode to be deployed when a specific volume is desired. Example, in case of neonates, this is the neonate mode. Breaths are completely controlled by the machine. What are the key parameters that allow this mode adjusts? Tidal volume, MAP-IE ratio and respiratory rate, flow rate, inspiratory and expiratory flow rate. In this case, pressure is still indirectly controlled because it is a dependent variable. Note that volumes that you are looking at are 4 to 6 ml per kg for the neonates. They are quite small volumes, right? In this in such volumes, dead space, anatomical dead space is huge, and small errors can have devastating consequences. So, may have dangerous consequences or devastating consequences. Something to keep in mind, that in neonates you want to have small volumes. Although volume is controlled, it is still possible that one of two barotrauma or volutrauma can still happen. So, there is a need to continuously sense and use feedback control to ensure that there is no damage to the baby. The third is pressure controlled assist control mode, or PC ACV mode. In this case, this is an assistive mode that does allow spontaneous ventilation. In the previous case, there was no spontaneous. In this case, there is spontaneous. In this case, pressure is the set variable, volume and flow change as per the condition of the patient and the respiratory mechanics and the lung mechanics. This mode assists to complete the target breath. So, the patient may initiate and the ventilator may finish. Now, usually it is the negative inspiratory pressure that is used to initiate the inspiratory cycle. The breath is, it says patient cycled, that is actually a misnomer, that is not the correct way to say that, that is actually it is patient triggered. This is quite often used to wean patients from the ventilators, and these are the key parameters that are used for adjustments. In this case, this represents essentially a paradigm shift that allows interaction with the patient. In such cases, it is important to make sure that you have some measure of asynchrony between the patient and the ventilator. Such an index is called as a trigger asynchrony index. It is a measure of how much less synchronous the patient is with the ventilator, or the ventilator is with the patient. This is essentially missed triggers plus auto triggers divided by total number of breaths times 100%. This percentage must be less than 10. This percentage must be less than 10 to assume minimal asynchrony. If it is more than 10%, that means that there is substantial asynchrony between the patient and the ventilator. So, you need to maybe you need to adjust the sensitivity of your sensors, for example, something to look at. Then you have volume controlled assist control ventilation mode. This is again an assistive mode that allows spontaneous breath. Volume is the set variable, whereas pressure and flow change as per the lung mechanics or the condition of the lung. This assists to complete the breath as the patient is this. Again, it is a negative inspiratory pressure that is usually used. In this case, because this is volume controlled, a target tidal volume will be delivered, which is compensated by the ventilator. Whatever is again, when you say patient cycle, that is essentially patient triggered, right? It is patient initiated or patient triggered. These are the key parameters that can be adjusted in this case, like tidal volume, MAP, inspiratory flow, and trigger. The next is pressure controlled SIMV or pressure controlled synchronous intermittent mandatory ventilation. This is an intermittent ventilation mode, which means that spontaneous breath is possible. Pressure is the set variable, and volume and flow are the dependent variables that emergent variables that depend on respiratory and lung mechanics. This mode allows spontaneous breaths between the mandatory breaths and then syncs the mandatory cycle. In this case also, the tidal volume will be delivered, or in this case this is pressure control. So, the pressure will be delivered, the pressure will be maintained, this is not correct, and in this case the breath is controlled by the machine. Something to keep in mind. VC, ACV we already took a look. With this we come to the end of this video. This video we looked at modes of ventilation, the taxonomy of ventilator modes and the common ventilation modes. Some things to keep in mind: complex does not mean better. Sometimes simple systems may actually be more helpful. Sometimes people think that pressure modes are better. This is also not true. Pressure modes will not cause volute trauma, will not cause ventilator induced lung injury, will not cause VILI. This is also not true, because it can still cause volute trauma. Patient triggering is always good. It is also not true, because if patient is triggering always, sometimes it might cause respiratory alkalosis. When will this happen? When will respiratory alkalosis happen? Check this. In one of our earlier videos we said when will respiratory acidosis happen and when will respiratory alkalosis happen, because sometimes when the patient is triggering in the ventilator, it might cause respiratory alkalosis, right. Sometimes people think that one mode throughout treatment. This is not true. As the patient is improving, false. This is false, because as the patient is improving, you may need to change the mode. Ventilator does not do all the work. It is absolutely interaction of ventilator and patient is absolutely critical. This is where we can improve. Is absolutely critical in almost all the cases, right. Settings are not absolute. The settings that you give are not absolute and need continuous adjustment, and you may need to listen to alarms. With this, we come to the end of this video. Thank you very much for your attention.